Hello everyone, myself PIYUSH and TANDEL working as Assistant Professor in Electrical Engineering Department of Mahatma Gandhi Institute of Technical Education and Research Center. And my name of subject is Industrial Instrumentation, which comes in 4th year 7th semester. And today we are going to start our chapter number 2, that is strain gauge and strain measurement. And this is the first video of chapter number 2. This is module 2.1. So starting with flow of content. So in this video lecture we are going to study introduction to strain gauge, then after strain stress relationship, after that factor affecting strain measurement, followed by types of strain gauge like mechanical gauge and electrical strain gauge. So moving forward, introduction to strain gauge. When a force is applied to a solid at rest, so solid at rest we are applying some amount of force, it gets mechanically deformed to a certain extent. Either we are going to give a compressive force or tensile force. Depending upon the type of force, it get mechanically deformed to a certain extent. If the force is tensile force, the length of solid increase, while if the applied force is compressive, the length of solid is decreasing. And the ratio of change in length, that is delta L, it may be increasing or decreasing. If we are applying a compressive force, at that time the delta L is going to be reduced, or we can say from the main length the delta L change in length is going to be changed, that is the reduce in length. And if we are applying the tensile force, at that time the value of delta L is going to be increased from the main length. So the delta L, that is the original value of the rod minus the changing rod, or we can say the after the applying the force, the length of the rod is called as the longitudinal or axial strain. So it is defined by E is equal to delta L by L, where delta L is equal to the change in length, that is before the force and after the force, right? And we know that the atom in a solid are bounded together by interatomic force, right? If no force act on the solid, the atom maintain definite distance among themselves at a given temperature. Then in equilibrium, the distance are called as a interatomic distance or bond length. Now what's happening? The bond length increase or decrease when a force is applied to solid. Then because of the existence of interatomic force between that bond, force of restitution act on restoring the atom to the existence of interatomic force, right? That's why the energy that required by the material, or we can say by required by this rod in this example, that is depend upon the interatomic force of that particular material. Now the stress is a reaction that is equated to applied force per unit area. It means it is defined as a applied force per unit area, that is longitudinal stress. So S is defined by F, that is the force, and A, that is the area, where S is the longitudinal stress and F is force applied on the area of A. Now the relation, that is the relation between strain and stress. So strain and stress have some relation, right, within the elastic limit. Now what is the elastic limit? Okay, elastic limit, it means suppose we are dealing with a metal rod. At that time what we are going to do, if we are applying a tensile force from the both the side of the rod, its size is going to deform, or we can say its shape is going to be deformed, or its length is going to be increased than its original length, right? So after certain amount of force, or after increasing certain amount of length, the rod is going to be in breakdown, right? So that limit of breakdown, that is called as a elastic limit of that particular material or particular rod. If different material have different elastic limit, right? The stress strain relation is given by the Hooke's law. And what is Hooke's law suggests? It is given by stress by strain, or we can say E, that is the Young's modulus of elasticity of different material. Okay, this E is going to vary from different material to material, and S is the longitudinal stress in kg per meter square. And over here, this E, that is the strain, that is this small e is the longitudinal strain. When a body of a length I is elongated by the B, so B delta L is the elongation owing the application of a force F. So whenever we are applying the force F, its length is going to be changed as a delta L. Its perpendicular dimension D contracts to the delta D. So if we are increasing the length of the rod by applying the tensile force, its diameter is going to be reduced because length is going to increase and diameter is going to be reduced. So over here delta L is going to be increased and delta D or delta D, that is going to be reduced. The strain generated in the particular direction is called as a lateral strain. So over here from the figure we can see that if we are applying a tensile force from both the side, the length that is going to be increased. So here original length, that is the L, and here the length that is increased, that is delta L. So over here and over here our length is going to be increased, so L plus delta L. So this is the change in length. And the same hand, what's going to be happen, its dimension, that is the diameter of that rod, is capital D over here. And whenever we are applying a force and tensile force, the diameter is going to be reduced, so the D minus delta D. So delta D is the change in diameter. So this is called as a delta D, and this is the previous, or we can say after the application of the force, our diameter is going to be exist like this. And now the PIYUSH show that the ratio between lateral strain and longitudinal strain is constant for a material. Okay, it is called as a PIYUSH ratio and is defined as V. So V is equal to delta D by D. It means this is the change in diameter of the rod divided by the change in length per the actual length. So what is our delta D by D? It's our change in diameter of the rod. And what is delta L by L? That is the change in length of the rod divided by the actual length, right? So moving forward, here are some factors that are affecting our strain measurement, and this topic is very important with respect to your examination also. So we restrict ourselves in the transducer related to the measurement of longitudinal and or we can say axial, because all the strain are found in the same form, right? So for the axial strain, the change in length are so small that it difficult to measure such displacement directly. So because the change in length, or we can say change in the length of that particular measuring device is very small, so it is very difficult to measure that displacement directly. Hence we need some kind of strain gauge. So strain gauge are used to measure that kind of small measurement or small displacement that are going to be occurred in our system, right? So the factor to be considered while measuring the strain are, first one, that is the measure strain in a constant solid. One has to measure AX and AX means actual area, and X, that is the after the any kind of force in a particular direction. Generally the strain magnitude is of few microstrain, and microstrain is a unit that is frequently used in strain measurement because the displacement that are going to be occurred in our strain measurement system is very small. That's why we need to measure it in microstrain. So microstrain is defined as the change in length in micrometer per unit meter of the length. So we can see that microstrain is equal to delta L in micrometer, okay, divided by the actual length, that is in meter. So whatever we are going to see over here, that is the change in length is in micrometer and actual length is in meter. That's why we can measure it in a microstrain. So it is equal to the actual strain magnified by 10 times. Okay, this is how we can measure a small strain, or we can say small displacement in our system. Strain are likely to vary from point to point. It required that a strain gauge must be as small as possible. We can put it anywhere, any place. That's why we require as small as possible, and the gauge is the length of gauge is 5 mm. So it is very small. You can see that over here it is from the 5 mm only. Now we are going to discuss different types of strain gauge. Okay, so the strain gauge can be classified as mechanical, optical or electrical depending upon the principle of operation. Whatever the principle we are following, it can be depending upon mechanical or optical or electrical and their constructional features, right? So how it can perform its measurement. The electrical resistance type gauge are commonly used because they are advanced in measurement. So we are mostly using the resistive type. So change in resistance type gauge for our electrical measuring device. Now the next one, that is the mechanical gauge. So what is mechanical gauge? In a mechanical gauge, the change in length is magnified mechanically using the levers of gears. So we can also use levers of gears to define that change in length. The easiest strain gauge were mechanical devices that are measured strain by measuring the change in length and comparing it with the original length of the object. For example, extensometer used in a series with lever to amplify strain to a readable value. So we can read that value. Actually the value of that displacement, mechanical displacement, is very small, so we need to amplify that for the readable scale. And however, the mechanical gauge are used for static strain measurement. They provide low resolution and are bulky because the resolution of mechanical gauge is very poor. That's why we cannot use in our electrical system the mechanical gauge, or we can say very rarely we can use the mechanical gauge in our system. Now this is how mechanical gauge is going to be look like. And next one, that is the optical gauge. Okay, optical gauge is little bit interesting thing. Right now they are similar to the mechanical gauge, except the magnification is obtained with the multiple reflection of mirror. Right now what we are using, mirror or prisms. So we are reflecting our results with the help of mirrors and prism in optical gauge. That's why its name suggests optical gauge. Okay, the inertia of the system is reduced. Okay, this is because of the using the mirror and prism. In mirror type extrometer of the Martin, a plant mirror is attached to a movable knife, that is the knife edge. At the edge we are attaching our mirror. When subjected to a stress, mirror rotate through an angle. Okay, if we are going to apply a tensile or compressive stress, depending upon that, the angle of knife is going to be rotated and the reflected light beam from the mirror subtend to an angle twice that of the incidence of the light. Okay, so the angle of that mirror is going to be changed twice that the applied force. So this is how we can magnify our results. They are independent of variation in temperature. The measurement of accuracy is very high using this optical gauge. So this is how your optical is going to be look like. So this is the input light and reflected light and transmitted light. So over here, as we can see, reflected light, transmission light, we have our dip over here, as we can see. So this is how it is going to be work, and we can use a fiber core for using the optical gauge. Okay, next one, that is very much of important for our aspects of electrical, that is electrical gauges. So we are going to study different type of electrical gauges in this chapter. So starting with the change in resistance or inductance or capacitance, whatever we are going to be changed, that is resistance, inductance or capacitance, are measured using the electrical strain gauge. So we are applying any kind of force, that is mechanical, either compressive or tensiling. Depending upon that force, the gauge's resistance, inductance and capacitance is going to be changed, and we are going to measure it electrically. The value measured in the proportion to the strain. So whatever strain we are applying, the value is going to be proportion to that. In inductance, the capacitance based strain gauge are used for specific applications. Strain gauge is passive transducer, or we can say passive resistance transducer, which convert mechanical elongation and compensation into the resistance change. The piezoresistive effect describes the change in electrical resistivity of a semiconductor when mechanical stress is applied on the piezoresistive device. Hence, the resistance strain gauge are called as a piezoresistive gauge. So, whenever we are applying mechanical force to piezoresistive material, we can change in our resistance. So, this is why we can call it as a piezoresistive gauge. I hope all of you get this point, and from next video we are going to study different type of electrical strain gauge, and here are some important questions regarding this subject and this video we can consider. And thank you. If you have any kind of query, please feel free to ask me in comment section. Thank you.